Good morning. Welcome, everybody. My name is Stoica. I am the director of the RISE Lab. And we hope that you are going to enjoy the RISE Camp. We have a very exciting agenda. So let me go a little bit about what you should expect in this RISE Camp. But first of all, what is RISE Lab? As many of you may be new to it. RISE Lab is a lab at Berkeley. We study the design of real-time intelligent, secure, and explainable algorithms and systems. And by real-time, we mean systems which can respond in seconds or even milliseconds. By intelligent, we mean systems that can make the intelligent decision, maybe using sophisticated machine learning algorithms. By secure, we mean that system which makes the decisions while protecting the data confidentiality and protecting the system and the data integrity. And by explainable, we mean decisions which are auditable, which are verifiable. You can explain why a particular decision has been made. And this is a holistic effort which includes over 10 faculty across AI, security, hardware, and systems, and is supported by many of you, the companies of many of you here. Thanks so much for that, and by National Science Foundation. So what are the RISE Camp goals? So there are a few goals here. So first of all, we want to share with you what we've built so far. So we are going to have a bunch of tutorials and talks where we are going to talk about our latest progress on building new systems and artifacts, as well as some of our plans for the future systems. Of course, we want to answer all your questions, so please don't hesitate to ask us any questions you may have. We want to get your feedback and hopefully your help. And thanks, many of you here already are helping us to developing some of these systems. And finally, the goal here is to bond and have some fun. So again, the main RISE Lab goal is to develop open source platforms, tools, and algorithms for real-time intelligent decisions on live data, decisions which are secure and explainable. And to do that, our main artifact is this RISE stack. It has many boxes. I'm not going to go through them, and we are only going to touch a subset of them during this RISE Camp. This stack is composed of 3 layers. One is a platform. Think about platform like security, resource management, storage. Then execution, and here we are going to have a bunch of general processing frameworks and applications. And like I mentioned, during this RISE Camp, we are going to have several tutorials, mainly today, and talks, mainly tomorrow. So what are the tutorials? First, we are going to have a tutorial, I guess it's like almost 5 tutorials about Ray and its libraries. And to put Ray in perspective and what we built it, let's start with the fact that today we are seeing 2 clear and major trends. One is that the demands of the applications far outstrip the increase of the capabilities of the hardware. This is a plot from OpenAI which shows the number of flops on the y-axis required to train the state-of-the-art models. And on the x-axis, you have the year, the time, and it's a log scale. This basically says that the amount of computation required to train the state-of-the-art models increases 35 times every 18 months. Okay? As you know, why it's 18 months I put here, because 18 months is a Moore's law period, and basically Moore's law was doubling 2 times, doubling every 18 months. And obviously we know that actually the Moore's law has ended for some time. So as you can see, the discrepancy between the requirements, the increase of the requirement of these applications and the capabilities of the hardware we are building is huge, and it's going to become even bigger. So this means there is no choice but for this application to go distributed. The second trend we see is that for the application are becoming more and more complex. If you look at the application today, they include data processing, they include maybe streaming, training, serving, model serving, hyperparameter search, and many more. Okay? So Ray is basically our answer to these trends. And it's a general purpose distributed computing framework for Python and Java. And on top of Ray, we also build some libraries for different workloads, including data processing, reinforcement learning, hyperparameter search, and we are also going to show you a prototype today of serving library, model serving. Another tutorial you are going to hear today is about AutoPandas, which in basically it's one line explanation. Is a Stack Overflow for Pandas. As you know, Pandas is the most popular library for data scientists using program synthesis. So at the high level, you provide the program with the input of output examples. So exactly like you would ask in Stack Overflow, how do I turn these data frames into these other data frames? And hopefully AutoPandas will come with an answer telling you how to do that. Tomorrow, the only tutorial I believe tomorrow, it's federated XGBoost. As you know, XGBoost is one of the most popular models and successful models in use today. And this is collaboratively learning an XGBoost model while keeping data private over many devices, say mobile phones. Then we are going to have several talks. One talk will be about Cerebro, which is a competitive machine learning platform. And let me explain what competitive means. Competition means a collaboration between business competitors in the hope of mutual benefits. Like multiple banks, although they compete, they may want to collaborate to improve their fraud detection capabilities. Okay, by hospitals may collaborate to improve their ability to diagnose the patients. Okay? So at the core, this is machine learning over multiple data sets, confidential data sets, and these data sets may belong to competitors. So federated learning and competitive learning are related, but are not the same. Federated learning is, again, think about you want to learn a model across your many mobile users, while here you have a few corporations which you want to put together, which may compete, which want to put together their data because they want to develop new capabilities from which all of them may benefit. Then you are going to hear one talk about AirDosh, which is a new platform for self-driving cars we are developing here, and a talk on serverless, where you are going to hear some of the latest research in the serverless area we have been doing at Rice Lab over the past year. So this is what you are going to see and what you are going to hear. And please, please join the Rice Camp Slack channel, and you can ask any questions, and we are going to try to be responsive and answer those on the Slack channel. We'll try this for the first time this year, so let's make sure it's a success. Okay? You have this also on the program, right? It should be on the program. Finally, if you have any questions, our wonderful staff is ready to help. Kat, Boban, David, Shane, and John in the back. So thank you very much. Hopefully you have a very productive and fun Rice Camp. And thanks again for your support and for being here.